everyone. Today's lesson is on circumference and area of circles. So let's get started with a warm-up. And the warm-up is to find the areas of the following figures. So the first one is a trapezoid. And what we learned from other lessons was that the area of a trapezoid is equal to the height divided by 2 times the sum of the bases. So we need to know what the height is for this shape. I see that it's an isosceles trapezoid with these two sides being equal. So what we're going to do is we're going to draw in a height, which is perpendicular to one of the bases. What we have so far is we don't have the height yet, but we do have both bases. So we can say that 6 plus 12 is equal to the area of our trapezoid. Okay, so in order to find the height, right here, we do know because it is isosceles that the distances here and here are going to be equal. So if this is 6 right here, this is also 6, which makes this 3 and that 3 to equal 6, which makes my height equal to 4. So it's going to be 4 divided by 2 times the sum of the bases. So that's 18. Normally, I'm just going to divide this out. 4 divided by 2 is 2. Times the sum of the bases, which is 18. So that my area of my trapezoid is going to equal to 36 units squared because it is units times this unit right here. So that's the area of my trapezoid. For this shape right here, this is the area of a triangle, and the area of a triangle is equal to 1/2 base times height, where the base is perpendicular to the height. So you do need to remember this bit of information. It is so important. Also, another idea is keep in mind that you cannot use the area, this formula, 1/2 ANS, because this one is only for regular polygons, and this is not a regular polygon. Okay, so we're going to use the 1/2 base times height. So we've got 1/2. I do have my base already. My base is 2. So we have 2, and all we need is our height. But because we know that our height has to be perpendicular to our base, this length right here is actually my height. Even though my base is way out here, my height is going to come down perpendicular. What I know is in order to find this length here, my height, let's see. I know that this is a 180-degree angle, which makes that a 45-degree angle right there. And if that's 45, that makes this also 45. So this is an x root 2. So what I'm going to do in order to find this side is I'm going to divide 8 by 2, so I get 4. And then I have root 2. So my height is actually 4 root 2. And if you forgot how to do that, so that's 4 root 2. If you forgot how to work this out, you have two options. You could, number one, just call that x, and that's 8. And then you can use Pythagorean theorem, like x squared plus x squared is equal to 8 squared to solve for that length. The other option is to take 8 and use the shortcut. You would be dividing by 2 and multiplying by root 2 at the same time. And that is because you set x root 2 equal to 8, and that's a special right triangle. For the area of our triangle, we've got the 2's are going to cancel, and so our area of our triangle is equal to 4 root 2, and that's going to be unit squared because we have units times units, and so that's the area of our triangle. Warming up. The warm-up continued. We have a rhombus. And for a rhombus, we know rhombuses have all sides are congruent. So if all my lengths are 8, okay, and side length 8 and an angle of 60 degrees. So this looks like a 60-degree angle right here. What I'm going to do with that is I'm going to make a right triangle in here because I know the area of a rhombus, all right, with my diagonals are perpendicular. I'm actually not going to use the diagonals. The area of a rhombus is 1/2 diagonal 1 times diagonal 2. And in this case, if I were to use the diagonals, which I don't have right here, so what I would need to do is I'm going to say this right here, which is a rhombus, is actually also a parallelogram. So the area of a parallelogram, okay, is equal to base times height, where my base is perpendicular to my height. See, in this formula right here, I would need a little bit of additional information in order to find what my diagonals are, which I don't have. Falling back on the fact that this is a rhombus and a rhombus is a parallelogram, I can use the parallelogram's formula, which is base times height, where the base is perpendicular to the height. So I know that my base is 8, okay? I know my base is 8. Now all I have to do is find my height. And so in order to find my height, across from, if that's 60, that makes that 30. Across from the 90 is equal to 2a. So that means a, which is across from my 30, is equal to 4, which means that across from my 60 is going to be 4 root 3. So this will be 8 times 4 root 3. So that's going to be 32 root 3, and that's units squared. Now that's the area of this rhombus using the parallelogram formula. Now, let's just go back and think, well, is there any way at all I can use my rhombus formula, which is 1/2 diagonal 1 times diagonal 2? Well, if I were to say that these are all 8, which we know they are, and I drew in my diagonals, we know that for a rhombus, our diagonals are perpendicular. We also know that if this was 60 degrees, okay, that the diagonals of a rhombus do cut that into 2 equal parts. So they are both 30, which then would mean that this is equal to 2a, this being 60. A would equal to 4, that being across from here. And then across from the 60 would be 4 root 3. Now let's think about that. If I used this formula, area of a rhombus, so area of a rhombus where my diagonals are perpendicular is equal to 1/2 the first diagonal times the second diagonal, I would get 1/2 the first diagonal, which is 4 plus 4, which is 8, times the second diagonal, which is 4 root 3 plus 4 root 3, which is 8 root 3. And so I would then take this 2 and divide it into 8, one of these, not both, just one. And that's 4. And 4 times 8 is 32 root 3 units squared. So I actually have options in doing this using a parallelogram formula or using my rhombus formula. So today's all about finding the area and circumference of circles. Now, we know that the circumference is 2 pi r, r being with a radius of 1, 2 pi all the way around a circle of radius 1 is 2 pi. In Algebra 2, we're going to learn a lot about this unit circle here with a radius of 1. And if we know that from here to here, well, from here to here is 90 degrees. This is 180. Keep going. That's 270. And then all the way around is 360. But if this is a radius of 1 and it is a unit circle, then all the way around would be 2 pi. And we call that radians, 2 pi radians, meaning halfway around would be 1 pi radian. Halfway of that would be pi over 2 radians. And this would be 1.5, which is 3/2 radian. And then this would be 1 plus another half, which is 2 pi. So all the way around a circle, we call 2 pi radians. And that's if the radius is 1. The area, which is always the space inside of the shape, is going to be pi r squared. So for this problem right here, it says to find the circumference and area of the circle that has a radius of 7. So we have our circle with our radius of 7. So to find the circumference, we're going to go 2 times pi times my radius, which is 7. And so this is going to be equal to 14 pi. If this is circle with a radius of 7, it didn't say, I'm just going to call this units, okay? And for the other one, we're going to have to find the area, okay? To find the area of this shape, we're going to go pi r squared. So pi r, which is 7, radius 7 and 2 root circle with radius of 7. Find the area. Find the circumference and area. This looks like we have two separate questions. So this one, pi r squared, 7, which is going to be 7 squared. Okay, so that's going to be 49 pi units squared, because it's 7 units times 7 units, which is 49 units squared. So this is the area right here, and this is my circumference, which is just units because it's 7 times 2. In order to find a circle, the area and circumference of a circle that has a radius of 2 root 5, okay, so here's 2 root 5, we're going to go circumference is equal to 2 times pi times my radius, which is 2 root 5. Something to remember is that your numbers get multiplied with numbers, so 2 gets multiplied by 2. So that's going to be 4 pi, and that'll be what, root 5. And that's my circumference, and that's units, 4 pi. Let me fix that. 4 pi root 5, and that's units. And then to find the area for this shape, we're going to go pi r squared, so 2 root 5 quantity squared. So that's going to be pi times 2 root 5 times 2 root 5. So again, numbers get multiplied with numbers. So area is going to equal 4 root 5 times root 5, which is root 25, which is 5. So that's going to be 4 times 5 times pi. And so that's going to be 20 pi units squared. And that's the area of the circle that has a radius of 2 root 5. So in this problem right here, we have a basketball rim that has a diameter of 18 units or inches. So we have, here's the diameter of this, and that's 18, which means that my radius is 9. Find the circumference of the rim and the area. So they are looking for the circumference and the area. So the circumference is equal to 2 pi r. In this case, we've got 2 times pi times my radius, and my radius is 9. So that's going to be 18 pi. So that's my circumference, units. Now, or actually inches. Just a note on this problem, inches is my circumference. 2 radii is equal to a diameter. So I could also have used this formula, circumference is equal to pi times my diameter. And in that case, I would have said pi times my diameter. My diameter is 18, so I get 18 pi. To find my area, it's going to be pi r squared. So the area is going to be pi times 9 inches times 9 inches, which is going to be 81 pi inches squared. And you always put your units after pi or radicals or whatever, units of measurement, whatever values you're using. So for this problem right here, we have 2 problems. We're trying to find the perimeter and the area for the following regular polygon. So I actually could use my 1/2 ANS if I wanted to, or I could use I could use the triangle formula. So we know that this is a regular polygon. There is a triangle inscribed to the circle. The radius is 1. We know that this length comes down here, and it is perpendicular. That's our apothem. We know that because this is a regular polygon, each of these angles is 60 degrees. We know then that this angle, this is split, bisected to 30, and then there's my 60 degree up there. I know that across from the 90 is 2a. So that means that A, being, and this also being my apothem and my value across from my 30 degrees, is 1/2. Across from the 60 degrees is going to be 1/2 root 3. So in order to find the length of, or my perimeter, I need the length of one side. So the length of one side is 1/2 root 3 plus 1/2 root 3, which makes 1 whole root 3. And so because each side is going to be root 3, I've got root 3 plus root 3 plus root 3, which makes 3 root 3 units. And so that's my perimeter, okay? In this case, for the area, if I use the triangle area, but to find the area of the triangle, I'm going to go 1/2 my base, which I know is √3, times my height. Now, this is what's a little bit tricky in that you need to remember that this is a median in this case, and a median does split up into 3 parts. This is 1/2 plus 1/2 plus 1/2. So that's actually 3/2. So 3/2. And I'm not going to cancel anything out here. I'm going to end up multiplying numbers with numbers. So this 3 is actually going to multiply by this 1 in front of the root. So 3 times 1 times 1, which is 3, √3 over 4. And that's the area of the triangle that's inscribed, and that's units squared. Okay. For the square that has a radius of 1, again, for this problem here, we know that these being 90 degrees, this is going to be 45, 45, 90. So x √2. So if I set this equal to x √2, basically I'm going to take 1 and I'm going to divide by 2 and multiply by √2, basically by dividing by √2. I'm going to multiply by √2 over √2. So I'm going to get √2 over 2. And so that length right here is this value right here, √2 over 2. And this is also √2 over 2. So the length of one side is √2 over 2 is 1/2 √2. So 1/2 √2 plus 1/2 √2 is 1 whole √2. And so all the way around is √2. So the perimeter is going to be 4 of those. So that's going to be 4 √2 units. And so that's my perimeter. For my square, for the area, that's just side squared. So if one of my sides is √2, that's just going to be √2 squared, which is the same thing as saying the area of my square is √2 times √2, which is the same thing as √4, which is 2 units squared. And so that's the area of the square that's inscribed in that circle. For this problem, you're going to find the perimeter and area of the following regular polygon inscribed in a circle. Now, this has a radius of 1. So this being 1, what I remember from being, let's see, it's a regular polygon. So we've got 1, 2, 3, 4, 5, 6. Well, that's a hexagon. Oh, there it is right there. Remember that the sum of the angles in any polygon would be 180 times n minus 2. So the sum of the angles in this polygon is going to be 180 times 6 minus 2, which is 4. 180 times 4 is 720 degrees. So the sum of all the angles inside here, and remember, they're all the same because it is regular, meaning all these lengths are the same. All I have to do is divide this by 6, and each angle is going to equal 120 degrees. So remember, if one angle is 120 degrees, when I cut that angle like that, okay, when I cut that angle like this, that makes this 60 degrees, okay? And what that means is that being 60 degrees, dermatology department, I think it's in the same building, it might not be. Well, I mean, whatever, right? Okay. Find, okay, you got it? Go to the front desk and ask them where dermatology is. It might not be in that building, Chelsea, okay?